concrete is the concrete that is in a solid state and has developed certain strength. Okay. And reaction continues with time and produce hard, strong and durable solid material. Okay. പിന്നെ നമ്മൾ പഠിക്കാനുള്ളത് ഒരു 4 പ്രോപ്പർട്ടീസ് ഓഫ് ഹാർഡൻഡ് കോൺക്രീറ്റ് ആണ്. നമ്മൾ ഇത് സിലബസിൽ കണ്ടില്ലേ, പ്രോപ്പർട്ടീസ് ഓഫ് ഹാർഡൻഡ് കോൺക്രീറ്റ്. അതിൽ മെയിനായിട്ട് ഒരു 6 പ്രോപ്പർട്ടി വരുന്നുണ്ട്. അതിൽ സ്ട്രെങ്ത് ഓഫ് പ്രോപ്പർട്ടീസ് ആണ് ഒന്ന് പഠിക്കാനുള്ളത്. പിന്നെ പഠിക്കാനുള്ളത് ഇലാസ്റ്റിക് പ്രോപ്പർട്ടീസ് ഓഫ് കോൺക്രീറ്റ്, ക്രീപ്പ്, ഷ്രിങ്കേജ്. ഈ 4 ടോപ്പിക്കാണ് നമ്മൾ ഈ മൊഡ്യൂളിൽ നോക്കാനുള്ളത്. പിന്നെ തെർമൽ പ്രോപ്പർട്ടീസ് ആൻഡ് ഫാറ്റീഗ് ഇതിൽ വരുന്നില്ല. നമുക്ക് മെയിനായിട്ട് സ്ട്രെങ്ത് ഓഫ് കോൺക്രീറ്റ്, ഇലാസ്റ്റിക് പ്രോപ്പർട്ടീസ്, ക്രീപ്പ്, ഷ്രിങ്കേജ്, ഇത്രയാണ് ഈ ഒരു മൊഡ്യൂളിൽ നമുക്ക് നോക്കാനുള്ളത്. ഓക്കെ, ഫസ്റ്റ് നോക്കാം നമുക്ക് സ്ട്രെങ്ത് ഓഫ് കോൺക്രീറ്റ്. ഓക്കെ, ഇപ്പൊ സ്ട്രെങ്ത് ഓഫ് കോൺക്രീറ്റിൽ നമുക്ക് മെയിൻ ആയിട്ട് ഒരു 4 ടൈപ്പ് കോൺക്രീറ്റ് സ്ട്രെങ്ത് പഠിക്കാനുണ്ട്. ദാറ്റ് ഈസ് ടൈപ്പ് ഓഫ് കോൺക്രീറ്റ് സ്ട്രെങ്ത്. നിങ്ങൾക്ക് അറിയാം എന്തൊക്കെയാ? കംപ്രസീവ് സ്ട്രെങ്ത് ഉണ്ട്, ടെൻസൈൽ സ്ട്രെങ്ത് ഉണ്ട്, ഫ്ലെക്ചറൽ സ്ട്രെങ്ത് ഉണ്ട്, ഇമ്പാക്ട് സ്ട്രെങ്ത് ആൻഡ് ബോണ്ട് സ്ട്രെങ്ത് സബായിട്ട് വരുന്നതാണ്. മെയിൻ ആയിട്ട് കംപ്രസീവ്, ടെൻസൈൽ ആൻഡ് ഫ്ലെക്ചറൽ സ്ട്രെങ്ത് ആണ് വരുന്നത്. ഓക്കെ, അപ്പം ഇതില് നോട്ട് നല്ല ക്ലിയർ ആയിട്ട് ഓരോന്നും എന്താണെന്നും പിന്നെ അതിന്റെ ടെസ്റ്റ്, കംപ്രസീവ് സ്ട്രെങ്ത് ടെസ്റ്റ് ചെയ്യുന്നത്, പിന്നെ സ്പ്ലിറ്റ് ടെൻസൈൽ സ്ട്രെങ്ത്, ഫ്ലെക്ചറൽ സ്ട്രെങ്ത്, 3ന്റെ ടെസ്റ്റ് നമുക്ക് വീഡിയോ കണ്ടാൽ നിങ്ങൾക്ക് ക്ലിയർ ആവും. എന്നിട്ട് നോട്ടിൽ ഞാൻ നല്ല ഡീറ്റെയിൽ ആയിട്ട് എന്താന്ന് പറയാം. ഓക്കെ, അപ്പൊ നിങ്ങൾക്ക് ഒന്നും കൂടെ ക്ലിയർ ആവും. നമുക്ക് നെക്സ്റ്റ് കംപ്രസീവ് സ്ട്രെങ്ത്തും ടെൻസൈൽ ആൻഡ് ഫ്ലെക്ചറൽ സ്ട്രെങ്ത് എങ്ങനെയാണ് നമുക്ക് ടെസ്റ്റ് ചെയ്യാന്ന് വീഡിയോയിൽ നോക്കാം. ഓക്കെ, ഫസ്റ്റ് ഈസ് കംപ്രസീവ് സ്ട്രെങ്ത്. Okay, compressive strength of concrete is defined as the strength of 28 days all specimen tested under uniaxial compressive load. അതാണ് നമ്മളെ compressive strength of concrete definition എന്ന് പറയുന്നത്. That is the strength of 28 days all specimen tested under the uniaxial compressive load. Okay, പിന്നെ പറഞ്ഞത് cubes, cylinders and prism are the 3 types of compression test specimen. നമ്മൾ സാധാരണ യൂസ് ചെയ്യുന്നത് മെയിൻ ആയിട്ട് ക്യൂബ്, സിലിണ്ടർ ആൻഡ് പ്രിസം ആണ്. 3 types of specimen എന്ന് പറയുന്നത് is used to determine the compressive strength on testing machines. ഓക്കെ, ഇനി പറഞ്ഞിരിക്കുന്നത് അതിന്റെ ഡയമെൻഷൻസ് ആണ്. ക്യൂബ്സ് ആണെങ്കിൽ the cubes are usually of 100 mm or 150 mm side. ഓക്കെ, ആൻഡ് സിലിണ്ടേഴ്സ് ആണെങ്കിലോ cylinders are 150 mm diameter by 300 mm height. Okay, and the specimens are cast, cured and tested as per standards prescribed for each test. അല്ലെങ്കിൽ ഓരോ ടെസ്റ്റിന് അനുസരിച്ചിട്ട്. അതുപോലെ കംപ്രസീവ് സ്ട്രെങ്ത് ഗിവൺ ബൈ ഡിഫറെന്റ് സ്പെസിമെൻ ഫോർ ദ സെയിം കോൺക്രീറ്റ് മിക്സ് ആർ ഡിഫറെന്റ് ആയിരിക്കും. നമ്മൾ 3 സ്പെസിമെൻ യൂസ് ചെയ്യുന്നുണ്ട്, ക്യൂബ്സ്, സിലിണ്ടർ, പ്രിസം, 3 എന്താ പറയാ സ്പെസിമെൻസ് യൂസ് ചെയ്യുന്നുണ്ട്. അപ്പം കംപ്രസീവ് സ്ട്രെങ്ത് ഓഫ് ഡിഫറെന്റ് സ്പെസിമെൻ ഫോർ ദ സെയിം കോൺക്രീറ്റ് മിക്സ് ആ ഡിഫറെന്റ് ആയിരിക്കും. ഇനി നമുക്ക് കംപ്രസീവ് സ്ട്രെങ്ത്തിന്റെ വീഡിയോ നോക്കാം, എങ്ങനെയാണ് കാൽക്കുലേറ്റ് ചെയ്യുന്നത്, ഐ മീൻ കണ്ടുപിടിക്കുന്നത്. ഓക്കെ, വീഡിയോ കണ്ടാൽ നിങ്ങൾക്ക് കുറച്ചും കൂടെ ക്ലിയർ ആവും. ഓക്കെ,
compressive strength test on concrete. The compressive strength of a concrete is defined as the ability of the concrete to withstand specific compressive forces. Compressive strength of concrete depends on many factors such as water-cement ratio, cement strength, quality of concrete material, quality control during production of concrete, etc. Generally, the specimens shaped in cube and cylinder are used for testing the compressive strength of concrete. The standard size of a cubical specimen is 150 mm into 150 mm into 150 mm, while the cylindrical specimen is 150 mm in diameter and 300 mm in length. Generally, the fresh concrete is prepared according to the required grades and the respective mix proportion. Once the fresh concrete is prepared, the inner surface of the mold is greased to avoid sticking of concrete. The prepared fresh concrete is then filled in mold in 4 layers. After filling each layer, tamping should be done for 35 times for cube and 25 times for cylinder using a standard tamping rod. Once the mold is filled, level off the top surface with a trowel. After a day, the mold is removed and the specimens are dropped into the curing tank, at a standard temperature of 27 plus or minus 2 degrees Celsius. After 7 days, the specimen is taken out of curing tank and dried for a while. Then, the specimen is placed on the compression testing machine. The cube specimen is just placed on the bearing plate, while for cylindrical specimen, it is placed vertically. The instrument is adjusted such that the plate touches the top surface of the specimen. The load is applied gradually over the specimen at the rate of 140 kg per centimeter square per minute. The load at which the specimen fails is noted. Thus, the characteristic compressive strength is calculated from the ratio of load and the area. The test is generally done with the help of 3 specimens and tested for 7 days, 14 days and 28 days.
Next is tensile strength. Okay, the tensile strength of concrete is much lower than the compressive strength. Well, because of the ease with which the crack can propagate under tensile loads, and tensile strength of concrete is measured in 3 ways. 3 വേസിൽ നമുക്ക് എന്ത് ചെയ്യാം? ടെൻസൈൽ സ്ട്രെങ്ത് ഓഫ് കോൺക്രീറ്റ് കണ്ടുപിടിക്കാം. ഏതൊക്കെയാ? ഡയറക്റ്റ് ടെൻഷൻ ഉണ്ട്, സ്പ്ലിറ്റിംഗ് ടെൻഷൻ അല്ലെങ്കിൽ ഇൻഡയറക്റ്റ് മെത്തേഡ് സ്പ്ലിറ്റ് ടെൻസൈൽ സ്ട്രെങ്ത് കണ്ടുപിടിക്കുന്നത്, അതുപോലെ ഫ്ലെക്സുറൽ ടെൻഷൻ. 3 വേസിൽ നമുക്ക് മെഷർ ചെയ്യാം. അപ്പം നമുക്ക് നെക്സ്റ്റ് ഒരു സ്പ്ലിറ്റ് ടെൻസൈൽ സ്ട്രെങ്ത് കണ്ടുപിടിക്കുന്ന ഒരു വീഡിയോ ഉണ്ട്. അത് കണ്ടാൽ നിങ്ങൾക്ക് കുറച്ചും കൂടെ ക്ലിയർ ആവും എങ്ങനെയാണ് നമ്മൾ ടെസ്റ്റിംഗ് മെഷീനിൽ വെച്ചിട്ട് ഇത് ടെസ്റ്റ് ചെയ്യുന്നത്. ഓക്കെ.
Split tensile strength test on concrete. In the split tensile strength test, the tensile strength of concrete is obtained by applying a compressive force along the length of the concrete cylinder. The specimen used for this method is of cylindrical in size and dimensions of 150 mm in diameter and 300 mm in length. The instrument used for this method is the universal testing machine. The specimen is prepared in the standard manufacturing procedure and placed on the mold in layers and tamped using 25 blows for each layer. After a day, the mold is removed, and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 7, 14 and 28 days for testing. Draw the line on the specimens as displayed on the screen. Then, record the weight and dimension of the specimen. The specimen is placed longitudinally in the machine. A bearing strip made up of plywood is placed on both sides of the specimen and align it according to the marking. Sometimes, supplement bars are placed on top of the plywood depending upon the diameter of the specimen. Now, apply the load continuously at a rate within the range 1.2 to 2.4 MPa per minute. Finally, note down the load at which cylinder fails by developing cracks. The resultant split tensile strength is calculated by the equation 2P divided by phi into D into L, where P is equal to load at which the specimen breaks.
And the third one is flexural strength. The determination of flexural tensile strength is essential to estimate the load at which the concrete members may crack. Okay, എന്തിനാണ്? To estimate the load at which the concrete members may crack. As it is difficult to determine the tensile strength of concrete by conducting a direct tension test, it is computed by flexural testing. Flexural testing machine വെച്ചിട്ട് നമുക്ക് ടെസ്റ്റ് ചെയ്യാം. The flexural tensile strength at failure or the modulus of rupture is thus determined and used when necessary. നെക്സ്റ്റ് അതിൻ്റെ ഡയമെൻഷൻസും കാര്യങ്ങളൊക്കെയാണ്. നമുക്ക് വീഡിയോ നോക്കാം. അപ്പം നിങ്ങൾക്ക് കുറച്ചും കൂടെ ക്ലിയർ ആവും എങ്ങനെയാണ് ടെസ്റ്റ് ചെയ്യുന്നത്. ഓക്കെ,
Flexural strength test on concrete. The flexural strength of concrete is an indirect method for measuring the tensile strength of concrete. The test is made on the beam of size 150 mm into 150 mm into 700 mm or 100 mm into 100 mm into 500 mm. Flexural strength of concrete is determined by either central point loading or two-point loading. The typical machine used for this test is shown on the screen. The bed of the testing machine is provided with two steel rollers of 38 mm in diameter. The rollers is mounted at the distance from center to center is 600 mm for 150 mm specimens and 400 mm for 100 mm specimens. The load applied through similar roller mounted at the top. In case of two-point loading, the rollers are spaced at 200 cm or 133 cm center to center. The concrete is prepared as per required grade of concrete and placed on the mold in layers and tamped 25 blows for each layer. After a day, the mold is removed, and the specimen is placed in the curing tank at a temperature of 27 plus or minus 2 degrees Celsius. Depending upon the requirement, the test specimen is removed from tank and dried at 14 and 28 days for testing. The specimen is placed on the rollers and centered with the longitudinal axis of the specimen. The load is applied at a rate of loading of 400 kg per minute for the 150 mm specimens and at a rate of 180 kg per minute for the 100 mm specimens. Finally, note down the load at which cylinder fails by developing cracks. Now, measure the distance between the line of fracture and the nearest support. Consider this as A. If A is greater than 200 mm for 150 mm and 130 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fb, is calculated by equation Fb is equal to P into L divided by Bd square. If A is less than 200 mm and greater than 170 mm for 150 mm and less than 133 mm and greater than 110 mm for 100 mm specimen, then flexural strength or modulus of rupture, Fb, is calculated by equation Fb is equal to 3Pa divided by Bd square, where B is the width of the beam in millimeters, D is the failure point depth in millimeters, L is the supported length in millimeters, P is the maximum load applied to the beam in kilograms. and A is the distance between the line of fracture and nearest support in millimeter.
Next is factors affecting strength of concrete. കോൺക്രീറ്റിന്റെ സ്ട്രെങ്ത്തിനെ എഫക്ട് ചെയ്യുന്ന കുറേ ഫാക്ടേഴ്സ് ഉണ്ട്. ഒരു 10-12 ഫാക്ടേഴ്സ് വരുന്നുണ്ട്. അതിൽ കുറച്ചെണ്ണം നമുക്ക് ഡീറ്റെയിൽ ആയിട്ട് നോക്കാം. ഓക്കെ, അപ്പം നെക്സ്റ്റ് നോക്കാൻ പോകുന്നത് ഫാക്ടേഴ്സ് എഫക്റ്റിംഗ് സ്ട്രെങ്ത് ഓഫ് കോൺക്രീറ്റ്. നമുക്ക് വീഡിയോ കാണാം, വീഡിയോയിൽ നിങ്ങൾക്ക് ക്ലിയർ ആവും. ഓക്കെ.
Strength of concrete. The quality of concrete is judged largely on the strength of that concrete. We all know that concrete is strong in compression but weak in tension. In most of the structural applications, concrete is employed primarily to resist compressive stresses. In the cases of concrete in tension or shear, the compressive strength is frequently used to measure these properties. Thus, we can see that the compressive strength of concrete is used as a qualitative measure for the various properties of hardened concrete. Generally, the strength of concrete is its resistance to rupture. It can be measured in number of ways, such as strength in compression, strength in tension, strength in shear and strength in flexure. These strengths of concretes are calculated by various methods which will be discussed in future videos. When concrete fails under a compressive load, the failure is essentially a mixture of crushing and shear failures. However, the mechanics of failure is a complex phenomenon. In general, the concrete in resisting failure generates both cohesion and internal friction. This cohesion and internal friction are related to a single parameter called as water-cement ratio. Besides, the strength of concrete is influenced by the following factors: ratio of cement to mixing water, ratio of cement to aggregate, grading, surface texture, shape, strength and stiffness of aggregate particles, and maximum size of aggregate. The water-cement ratio primarily affects the strength, whereas other factors indirectly affect the strength of concrete by affecting the water-cement ratio. Water-cement ratio of concrete. As we seen in the previous video on strength of concrete, the strength of concrete is mostly influenced by the water-cement ratio. Let's deal with it in this video. The water-cement ratio is also responsible for the porosity of the hardened cement paste. Water-cement ratio is stated as the amount of water used to the significant amount of cement in the mixture by weight. For proper workability, the water-cement ratio varies from 0.4 to 0.6. However, the maximum strength of concrete is obtained at a water-cement ratio of 0.4. Besides, we know that for a complete hydration of concrete the water requirement is about 38%. If the water-cement ratio is decreased less than 0.4, there may be improper consistency and workability. The typical graph for water-cement ratio against the strength of concrete is shown. The concrete with water-cement ratio of 0.3 compacted by vibrator also shows higher compressive strength, which is represented by the dotted line. As the curve is hyperbolic in shape, it is difficult to interpolate the values. Thus, for a geometrical purpose, the graph is sometimes drawn approximately linear as shown. If the water-cement ratio is more than 0.6, the hydrated products may not have much space fill as the water is already filled with it. Gel, Space ratio of concrete. Abraham's water-cement ratio law has several limitations. Researchers do not agree to call it a law, rather they said it to be a rule. In general, the strength at any water-cement ratio is a function of degree of hydration of a cement and its physical and chemical properties, temperature at which hydration takes place, formation of cracks due to bleeding and shrinkage, air content in case of air-entrained concrete, change in the water-cement ratio. With these, some of the researchers stated that the strength of concrete can be related to the hydration products, that is gel space ratio. Gel space ratio is defined as the ratio of volume of hydrated cement paste to the sum of the volumes of the hydrated cement and that of the capillary pores. A relationship between the strength of concrete and gel space ratio is established by Power and Brownyard. A typical curve relating gel space ratio to the compressive strength is displayed. The strength of concrete considering gel space ratio is calculated by S is equal to 240 x cube, where S is the strength of concrete, X is the gel space ratio, and 240 is the intrinsic strength of gel in Newton per millimeter square for the type of cement and specimen used. Effect of maximum size of aggregate on strength of concrete. In earlier days, the researchers thought that the use of larger size aggregates leads to higher strength. They thought that the larger the aggregate, the lower is the total surface area. Thus, a less amount of water required to get the desired workable concrete. So, a lower water-cement ratio can be adopted to get higher strength. Over the period, the researchers found that the large size aggregate does not contribute to the higher strength of concrete in real. This is due to the maximum size aggregate gives a lower surface area for developments of gel bonds, which is responsible for the lower strength of the concrete. And bigger aggregate size causes a more heterogeneity in the concrete, which will prevent the uniform distribution of load when stressed. There is also a possibility of internal bleeding, development of microcracks, which results in lower compressive strength. Besides, the influence of the size of the aggregate in lean mixes is less. Based on the research, the use of larger aggregate gives high strength in lean mixes, and for rich mixes use of smaller aggregate yields high strength. The influence of the maximum size of aggregate on compressive strength of concrete is shown in the graph. The graph shown represents the influence of the size of aggregate on the compressive strength of concrete for different water-cement ratio. Effect of compaction on strength of concrete. We know that the compaction of concrete is intended to expel the entrapped air and optimize the density of the concrete, in order to benefit most of the properties of hardened concrete. We have seen more about this in the video on compaction of concrete. Inadequate compaction leading to air void contents of 5% and of 10% result in a loss of strength of 30% and 50%, respectively. The effect of variation of compaction on the strength of concrete is calculated with the help of equation. S is equal to J into C divided by 1 minus rho minus N, where S is the unit compressive strength, C is the volume of cement grains in the unit volume of concrete, is the density of concrete, J and N is the constants. The effect of degree of compaction on strength is given by the given shown on the screen. The higher the density ratio, the higher would the concrete strength ratio. The highly compacted concrete yields higher density ratio, which in turn results in the higher strength of concrete. Effect of mixing time on strength of concrete. Generally, if the concrete is mixed for a longer period, results in uneconomical from the point of production rate. Therefore, it is important to mix the concrete for such a duration which will accrue optimum benefit. The strength of concrete increases with increase in time of mixing up to 2 minutes, beyond which no significant improvement is observed. In case of a machine mixer, the mixing time is related to the capacity of a mixer. The mixing time of it varies between 1 minute 30 seconds to 2 minutes 30 seconds. Bigger the capacity of the drum, more is the mixing time. The increase in strength with respect to increase of mixing time may be due to the improvement of workability because of excess fines formed due to the abrasion and attrition of coarse aggregate in the mix. However, the mixing of concrete over long periods results in the evaporation of water and formation of excess fines, which may reduce the workability and hence bring about a reduction in strength. The excess of fineness may also cause greater shrinkage. Thus, it is important to maintain optimal mixing time. Effect of air voids on strength of concrete. Air voids are generally formed because of the evaporation of the water used in making concrete and by entrained air. In general, air voids in the concrete depends on the water-cement ratio. There is an increase in the air voids with an increase in the weight of water. When this situation happens, then the strength of the concrete drops down. However, the hardened concrete contains about 1 of air voids. If the water used is more than the optimum water required for maximum strength of concrete, the concrete becomes permeable and susceptible to deterioration. The graph shown represents the reduction in strength with an increase in percentage air voids. Maturity concept of concrete. The strength of concrete depends upon both the time as well as temperature during the early period of gain in strength. The maturity of concrete is defined as the summation of the product of time and temperature. Its units are degree Celsius hour or degree Celsius days. Relation between compressive and tensile strength of concrete. We know that concrete is strong in compression, weak in tension. Thus, in most of the concrete construction, the compressive strength of concrete is taken into consideration. The tensile strength of concrete is ignored. Besides, the design of concrete pavement slabs, roads depends on the flexural strength of concrete. Therefore, it is important to calculate the flexural strength of concrete. We have some methods for determining the flexural strength of concrete. However, the determination of compressive strength of concrete are easier. Thus, obtaining relationship between compressive strength with flexural strength will help to determine the strength of concretes. Thus, today we are going to see the relationship between compressive strength and flexural strength. It is seen that strength of concrete in compression and tension, both direct tension and flexural tension, are closely related. From the extensive study carried out at Central Road Research Laboratory CRRI, the following statistical relationship between tensile strength and compressive strength were established. Where Y is the compressive strength of concrete in P and X is the flexural strength of concrete in P. The general relationship between flexural and compressive strength of concrete is given as Y is equal to 11x minus 3.4. The graph shown on the screen represents relationships between compressive strength and flexural strength of concrete for various aggregates. In general, the flexural strength of concrete was found to be 8 to 11% of the compressive strength of the concrete for higher ranges of concrete strength greater than 25 megapascals and 9 to 12.8% for lower ranges of concrete strength less than 25 megapascals. The flexural to compressive strength ratio was higher with aggregate of 40 mm maximum size than with those of 20 mm maximum size. In general, the ratio was found to be slightly higher in the case of natural gravel as compared to crushed stone. Gain of strength of concrete with age. In general, the strength of concrete is fast at the start and slow downs with the age. It is assumed that the concrete attains its full strength in 28 days. Actually, the assumption is false. The concrete develops the strength beyond 28 days too. However, the increase in the strength of concrete beyond 28 days is not considered in the design. To make the structures economical, the designers are working on to reduce the factor of safety consideration. The table shown on the screen shows the strength of low and high strength concrete for various months beyond 28 days. As per the S269, 1976 code, only one type of cement was considered to have increased in the strength after 28 days. However, after gradation of OPC, the present-day cements, particularly 53 grade cement, being ground finer, the increase in strength after 28 days is nominal. The most of the strength developments in respect of well-cured concrete will have taken place by 28 days. Therefore, in IS 456, 2000, the clause is revised. The clause states there is normally a gain of strength beyond 28 days. The quantum of increase depends upon the grade and type of cement, curing and environmental conditions, etc. The design should be based on 28 days characteristic strength of concrete unless there is an evidence to justify a higher strength for a particular structure due to age. Besides, it is also important to estimate the strength of concrete at an early age. It is not necessary to wait for 28 days to check the strength of concrete. Many researchers have attempted to estimate the strength of concrete at 1, 3 or 7 days and correlate it to 28 days strength. These relations depend upon many factors such as the compound composition of cement, fineness of grinding and temperature of curing, etc.
Hey guys. Welcome to Civil Mentor. Concrete is widely used building material in the construction world. Concrete is made up of various ingredients. And of course, all of them have different roles. The properties of concrete generally rely on the mixing of concrete ingredients, such as cement, coarse aggregates, fine aggregates, and water. The whole world wishes their structure to be strong and durable, and for that, they always design their structures according to the desired strength and service. Strength gives an overall indication of quality of concrete, as it is directly related to the lifelong performance of the concrete structure. The strength of the concrete shows the ability of the structure to withstand various loads such as dead load, live load, earthquake load, wind load, etc. The strength of the concrete can be measured with the different tests that are conducted on it, such as compressive strength, tensile strength, and flexural strength. Apart from the above tests, there are various factors that can also affect the strength of concrete. Highlights of those factors are described in this video. So, let's get started. "11 factors that can affect the strength of concrete." Number 1. Water-cement ratio. The ratio of the weight of water to the weight of cement is called water-cement ratio. It is the most important factor for gaining the strength of concrete. The lower water-cement ratio leads to the higher strength of concrete. Generally, the water-cement ratio of 0.45 to 0.60 is used. Too much water leads to segregation and voids in concrete. Water-cement ratio is inversely proportional to the strength of concrete. As shown in the chart, when the water-cement ratio is increased, the strength of concrete gets decreased. And when water-cement ratio is decreased, then the strength of concrete increases. Number 2. Compaction of concrete. Compaction of concrete increases the density of the concrete, because it is the process in which air voids are removed from freshly placed concrete, which makes the concrete compact and dense. The presence of air voids in concrete greatly reduces its strength. Approximately 5% of air voids can reduce the strength by 30 to 40%, as we can see in the chart. Even at the same water-cement ratio, strength is different, with different compaction accuracies. In the fully compacted concrete, strength is higher than the insufficiently compacted concrete. Number 3. Ingredients of concrete. The main ingredients of concrete are cement, sand, aggregate, and water. Quality of each material affects the strength of the concrete. All materials, therefore, should fulfill the standard criteria for use in concrete. Number 4. Curing of concrete. Curing of concrete is the most essential process to prevent plastic shrinkage, temperature control, strength development, and durability. Curing provides the desired moisture and temperature at the depth and near the surface, after placing and finishing of concrete, for development of strength. In other words, curing provides sufficient water to concrete for completing the hydration process without interruption, which is important for strength development. Commonly 7-day curing corresponds to 70% of compressive strength. Curing period depends on the types of cement and the nature of work. Generally, it's about 7 to 14 days for ordinary Portland cement. There are many methods of curing like ponding and immersion, spraying and fogging, saturated wet coverings, etc. Hence, please remember, use as less water as possible during concrete mixing, and use as more as possible after concreting. Number 5. The shape of aggregate. There are many shapes of aggregate, like angular, cubical, elongated, and flaky, irregular, and rounded. Angular aggregates are rough textured, and rounded aggregates are smooth textured. Thus, the rounded aggregates create the problem of lack of bonding between cement paste and aggregate. Angular aggregates exhibit a better interlocking effect in concrete, but the angular aggregate contains a larger amount of voids. For this, you needed well-graded aggregate. The shape of aggregates becomes more important in case of high strength and high performance concrete, where very low water-cement ratio is used. In such cases, cubical shape aggregates with uniform grading are required for better workability. Number 6. Maximum size of aggregates. Larger size aggregates give a lower strength because they have a lower surface area for development of gel bond, which is responsible for strength. Larger size aggregate makes concrete heterogeneous. It will not distribute loading uniformly when stressed. Due to internal bleeding, the problem of development of the micro cracks in concrete happens when larger size aggregates are used in concrete. Number 7. Grading of aggregate. Grading of aggregates determines the particle size distribution of aggregates. It's the most important factor for concrete mix. There are 3 types of graded aggregate: gap-graded aggregate, poorly graded aggregate, and well-graded aggregates. Well-graded aggregate contains all size of particles of aggregate, so that they have a less amount of voids. The use of well-graded aggregates gives higher strength to the concrete. Number 8. Weather condition. Weather condition also affects the strength of concrete, due to different reasons. In cold climate, exterior concrete is subjected to repeated freezing and thawing action, due to the sudden change in weather, which produces deterioration in concrete. With the change in moisture content, materials expand and contract. It produces cracks in concrete. Number 9. Temperature. With a certain degree of temperature increase, the rate of hydration process increases in which it gains strength rapidly. Sudden temperature changes create a thermal gradient, which causes cracking and spalling of concrete, so that the final strength of concrete is lower at the very high temperature. Number 10. The rate of loading. The strength of concrete increases with the increase in the rate of loading, because, at the high rates of loading, there is less time for creep. Creep produces permanent deformation in the structure at constant loading, so that the failure occurs at limiting values of strain, rather than the stress. In rapid loading, the load resistance is better than the slow loading. Number 11. Age of concrete. With increase in the age of concrete, the degree of hydration would be more. Hydration processes the chemical reaction of water and cement. Hydration produces the gel, which plays a significant role in the bonding of particles of the concrete ingredients. Therefore, the strength of concrete increases with its age. Normally, concrete strength gets doubled after 11 years.